Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Nur Anis binti Zaidi, and in this video, I will show a problem solving using instance photoelectric equation. Okay, for example 1, a blue light with a frequency of 6.67 times 10 power of 14 Hz is shown on a clean calcium metal surface. What is the maximum kinetic energy of electrons emitted? In order to answer this question, we need to do a few steps. Okay, step 1 is identify the problem. Okay. This statement tells us that a blue light with a frequency, this frequency shown on a clean calcium metal surface. Okay, we imagine we have a metal surface, and therefore there is a blue light shown on this surface with a certain frequency, and therefore the photon energy will be fully absorbed in this surface by the electron. Okay, this energy is used to release the electron from this metal, and the extra energy will become the maximum kinetic energy. Okay, so in this question, we want to find the maximum kinetic energy of the photoelectrons emitted. Okay, when we already identify the problem, okay, the next step is to find the info given. The info given is the work function. Okay, the work function 3.43 times 10 power of negative 90 joule, and the H Planck's constant is 6.63 times 10 power of negative 34 joule second, and then the frequency given is 6.67 times 10 power of 14 Hz, and we want to find the maximum kinetic energy. For the step 3 is we need to identify the formula that we need to use. Okay, based on this info, we need to use the formula of HF equal to W plus K max, and then we can substitute the value from the info given to find K max. We can use the calculator to find K max, which is 9.92 times 10 power of negative 20 joule. Okay, this is the answer. For example 2, figure 7.14 shows the change in kinetic energy of photoelectrons released from lithium for different light frequencies. Determine the threshold frequency from the graph and calculate the work function for lithium. Okay, firstly, we can see from the graph the threshold frequency. Okay, from the graph, we identify that the threshold frequency F naught is equal to 5.6 times 10 power of 14 Hz, and then the Planck's constant is equal to 6.63 times 10 power of negative 34 joule second, and then now we need to find the work function. Work function W equal to HF naught, therefore 6.63 times 10 power of negative 34 times 5.6 times 10 power of 14. So we can use the calculator, and the answer is 3.71 times 10 power of negative 19 joule. This is the work function at the threshold frequency 5.6 times 10 power of 14 Hz.